Hello, grade 8. Welcome to our science session, which about the matter construction. Firstly, start with matter. Matter may be solid or liquid or gas. Solid like pen or pencil, liquid like water or milk or oil, gas like oxygen or carbon dioxide. Any one of them consists of small particles called molecules, and the molecules consist of a smaller one which is called atoms. Here, as you can see here, for example, this perfume bottle, if you open it and leave it in a room for a period of time, you can find the smell everywhere because the molecules of the perfume move and spread everywhere and mix with the air molecules because they are in continuous motion. It means that it consists of small particles which is called molecules that cannot be seen by our naked eyes. So the molecule here is the smallest particle of matter that can exist freely. Freely means alone and carry or keep the properties of matter. Means still the same. If you cut any substance or any material into the small molecules, the small molecules carry the same properties of the matter itself. Now, what are the properties of molecules? Number one, all the molecules are in continuous motion, means not stop. But the motion in solid different from the motion from liquid or gas. The second one, you can find spaces between the molecules. These spaces we call it intermolecular spaces. These spaces are very, very small in solid, while medium in liquid and very large in gas. The third one, you can find attraction force between the molecules. This attraction force we call it intermolecular force. The force in solid very strong, so cannot bend easily. Medium in liquids, and the force very, very weak in the molecules or between the molecules of gases, so can move everywhere easily because there is no attraction between them. Now, what is the structure of the atom itself, the atomic structure, which is the very, very important part. Before we start this part of the lesson, okay, let's read here some examples of some elements, symbols of some elements. Like, for example, hydrogen, H, carbon, C, nitrogen, N, as you can see here, the first letter only. Sometimes, okay, to differentiate between two elements, for example, here, sulfur, S, and here, silicon, also S. But to differentiate between them, Si for silicon, but the first letter is capital letter, and the second one, small. You can find also a different part here. Okay, some elements we took the Latin name, like sodium, Latin name is natrium, which is so Na, and potassium K, and the same here, and the other elements. Now the most important part of our lesson, which is atomic structure. The atom itself, as we said before, the matter may be solid or liquid or gas, consists of small particles called molecules, and the molecules consist of atoms. What inside the atom? The atom, inside it, firstly, number one, which is called nucleus. Like the solar system, the sun in the middle, and the planets rotate around it. It's nearly the same. Here you can find the nucleus in the middle, like a circle. This nucleus contains two particles, number one, protons, and the second one, neutrons. But what is the difference between them? The protons carry positive charge, and neutrons neutral. Neutral means no charge. So again, the nucleus contains two parts, number one, protons, which carry positive charge, and the second one, neutrons, okay, which are neutral, means no charge. When you move outside the nucleus, you can find electrons. Electrons are very, very small particles that rotate around the nucleus that carry negative charge particles. rotate around the nucleus, okay, in very high speed, in places which is called energy levels, imaginary places, imaginary circles around the nucleus, which is called energy levels or orbits or shells. If you count the number of protons, positive protons inside the nucleus, or the negative electrons outside the nucleus, they are the same. In one of them, we call it atomic number. So atomic number equals the number of positive protons or the it's very important, or the number of negative electrons which are around the nucleus. So they are the same. Now go to the mass number. Mass number, if you count the number of protons and neutrons which inside the nucleus, okay, we call them the mass number. So again, to differentiate between them, if you count the protons only, we call it atomic number. If you count protons and neutrons, we call it mass number. So mass number is bigger than the atomic number. So again, mass number equals, or it is the sum of number of protons and neutrons which inside the nucleus. Now we can find many questions about the lesson and the answers. Now if you want to compare between protons, neutrons and electrons. Firstly, position. Where you can find each one. Number one, protons, it's already inside the nucleus. Also neutron inside the nucleus, while electron outside the nucleus or around it or on energy levels. What is the charge of each one? The protons positive charge, the electrons negative charge, while neutron carries neutral charge, means no charge. The mass here, no need for it, but it's okay, no problem. The mass of a proton very large if you compare it with electron. Also the neutron, it's very large also if you compare it with electron. The mass of a proton and a neutron nearly the same, but the mass of electron very small if you compare it with a proton or neutron, as it moves around the nucleus. So it's very light, so can move quickly around the nucleus. As you can see here, the energy levels, we have 7 energy levels as we said before around it, which are K, L, M, N, O, P and Q, and each one, as you see here, okay, carry a specific number of electrons. If we have any number of electrons and we want to put them on energy levels, how? I put these electrons, okay, according to the rule 2m power 2, as you can see here. So if you apply it, you can find K carries 2 electrons and L carries 8 electrons, and M 18 and N 32. We can apply it till the 4th energy level. So we can apply the 2n power 2 on K, L, M, N only. Why? Because any energy level, if you put more than 32, which is the maximum number, and N here, okay, if you put more than 32, all the atom will be unstable. So we can apply, as you can see here, the rule, this rule, we apply it on KLMN only to the 4th energy level only. Why? Because the atom becomes unstable. I think this part is clear now. Okay, we have some examples here. If we want to make electronic configuration for some elements, okay, you can find many examples here. Let's go for any one, for example, as you see here, potassium, K19. 19, as you can see, K carries 2, L 8, and M 8. So 2 plus 8 equals 10. 10 plus 8 equals 18. So we have still 1 from 19, because we said here, when you look at this part here, you can find 19 here. So if you count all the numbers here, 2, 8, 8, and 1, it will be 19. Why? Or how we apply, or how we put electrons. The first energy level, K, as we said before, K, 2 electrons, L 8, and M 8, so till now 18. So still 1 electron, so we put it in the last, or we call it the outermost energy level. So 2881. I think this part is clear now. Okay, thanks a lot, and see you in the next time, inshallah. Thanks a lot.